We've been using a high-speed camera to film hydrogen balloons exploding.
I like you, Neil.
It's given me the answer, or nearly given me the answer, to a question that's been puzzling me for years. Ever since our first element video, we've been using the match on a stick to blow up balloons of hydrogen. And the thing that's always puzzled me is that when they blow up, the flame has a reddish colour. And it's well known that hydrogen, when it burns, for example in a Bunsen burner or something like that, gives an almost colourless flame. So why should the balloon give a red flame or reddish flame when it blows up? And I came up with an idea on one of our videos that it may be the rubber of the balloon that's burning. Recently, I got an email from one of our viewers called Paul, who said he thought I was wrong. And he thought that the hydrogen in the balloon and the oxygen in the air are not properly mixed. So when the hydrogen starts burning, there's much more hydrogen than oxygen, and the heat from the first part of the flame heats up the rest of the gas, and the hydrogen gas gives out red light. We were quite interested to see if this was really true. And the obvious way to do is to film the balloon going off in high speed to see what happens to the rubber when you light the balloon. When we looked at the video, it was extraordinary. The rubber disappears and flies off into the air before the gas really starts burning at all. And you can see the flames slowly going through this mass of gas, sort of balloon-shaped mass of gas. So the orange colour cannot be anything to do with the rubber from the balloon because that's flown away. In one of our videos, it goes up towards the ceiling. So I was wrong. And it's always good for a scientist to be proved wrong. But now you've got to do an experiment to see what it might be. And Paul suggested an experiment. He said, try burning a balloon filled with a proper mixture of 2 parts of hydrogen and 1 part of oxygen. Water is H2O, so what you need is twice as much hydrogen as oxygen. This is what chemists call a stoichiometric mixture. That's a mixture that's just the right amount to give you the product. The problem is, of course, that it explodes with a very loud bang, and we were quite frightened. You know, it might be bad for all sorts of reasons. Since the gas is already mixed, the reaction will go faster, so you get a much bigger shock wave. So we've tried the experiment, and let's watch what happens. If you look carefully, you can see that as the flame touches the balloon, the reaction goes really fast. The balloon lights up like an electric light bulb before it's lost its shape at all. And then it slowly spreads the bright light, which is much brighter than with the hydrogen by itself, because the reaction's going faster, so the temperature goes up much higher. And what's interesting is that the flame separates into 2 parts from the point where you add the match. This is actually quite a well-known effect when there are gas explosions in people's houses, when they light a match when there's gas in their house. Very often the person who lights the match is okay because the explosion spreads away from them, and it does huge damage, and they're left in the middle feeling a bit stupid because the house has gone. It really looks as if Paul is right. That is, that the reaction goes completely differently. I really feel that I have learnt something about this reaction. I was talking to quite a senior physicist yesterday over lunch, and he was amazed that the balloon would burst and the rubber disappear before the hydrogen caught fire. And so was I, because it all happened so fast that normally one doesn't see this, and your gut feeling is that hydrogen explodes easily, so of course it'll blow up long before the balloon does.